Hi there, it's Dr. Everybody. We're going to take a look at project 4. And this one, we're reading a file, and then we're going to use string processing to extract data out of the file. Now, a particular characteristic of this file is that it's arranged in columns. So that allows us to use slicing to get at the individual elements in it. So we'll use string slicing to get information, get the data out of the file. It turns out we only need to look at 2 lines in this file. Lines number the 9th line and the 44th line, and we have to kind of connect them together. This is data that I got off from the Census Bureau, if I remember correctly. But it's just some real data grabbed off the internet. No, actually not the census. This is GDP data, gross domestic product data. And we're going to try and find out which years had the lowest and the greatest change from the previous year, and how big the domestic product was at that point. So I've grabbed a couple of tables and put them into a text file, and now we're going to go through those and extract stuff. So let's take a look at that. So in our project, what I do is I give you a little bit of description about where I got this data. One little note that's there is that I just make a little parenthetical note. It turns out that if you look at this data, some of this stuff has been adjusted, so it doesn't entirely add up right. So like if you tried to extract the line 9 from the line 44, you'll actually see that there's a difference in percentage. That's just for the curious. In terms of this project, that doesn't matter at all. And so what happens here is we give you a file, gdp.txt, and we're interested in the 9th line, which has the annual change in the GDP, and the 44th line, which actually has the value of the GDP. And it's important how this is arranged, because the data starts in column 76. There are 46 data items across there, and each of the data columns spans 12 columns. And what that means is that if you read a line and put it into a variable named line, then you can use the square brackets to do a slice with colon in between from the 76 column to the 76 column plus 12. And that's where the first item is, and then you just keep moving over by 12. So you add 12 onto here, and you add 12 onto there, and that gets you the next data item, and so on. Okay? And what we ask you to do is to find the minimum and the maximum change in the GDP. That is line 9. So we're going to look at line 9, find the minimum, maximum in it, and then go through and find the value. After we do that, we then go to line 44 and get the value out of that. So, and if we look at it, if we look at the output, the way this project works is we enter a file name. Yep, there's a check to see if we get the right one. Okay, that is the right one. And we go through, and then we find out the minimum change and maximum change in the GDP. We print out that value. We give the year that it's in. So we actually have to get more than just those 2 lines. We've got to get the lines with the year in it. Or you can actually calculate those. You get a choice there. I don't tell you how to do that. And then the data is in trillions of dollars, whereas note the file data is in billions. So you're going to have to do you just have to convert your billions to trillions, which is obviously a relatively easy thing to do for you at that point. Okay, so let's take a look at how we might go about that. here's the data file. I actually opened it in Excel just because that lines up the columns very nicely. And we can see that in the 9th line, here is where we get the change. So the 8th line has the year, and so change of 3.1 and 0.2 and so on. And then down at the bottom, we see the actual GDP value. And oops, let's get that back. There we go. That's readable. We see the actual value here. So in 1969, it was 1,000 billion dollars, obviously $1 trillion at that point. So what we're trying to do here is go through this line 9 and find which of these values is the smallest. Now it turns out that we can eyeball it, but we're going to ask you to do this with the computer. Is that it turns out that the minimum value is -2.8 that takes place in 2009. And so then what we want you to do is, out of the line 44, is tell me that this value here, this 14,418 or $14 trillion. Okay, so you're going to go across this row and find out which one is the minimum, and then find out the corresponding value in the other column. Now, so what that means is that once you locate that this is 2.8, you need to somehow keep track of the index of where you're at. And there's a lot of different ways you can do this. You can say, oh, well, this is like whatever it is, the 44th value that I have here. Or since we know each one of these is 12, it may be 41 times 12 in terms of the column number, or maybe you actually decide to keep track of the year. And, however you decide to do it, there's many ways to do it. Once you find the 2.8, you then have to use the index, however you keep track of it, so that when you look at this line 44, you come up with the right value. And at the same time, we do need to know the date that's associated with it. So that's a problem. All right, we come across here, we find the minimum, and then we find the corresponding value here. And then we go back, and then we go through and we find the maximum, and we do the same thing. So in terms of the code, we're also dealing with functions here. So I wrote a simple function that opens a file. This isn't the final one, but it gets me something to start with. And I can say FP, or let's call it in file, just so I have a different name. In file, this is what comes back when I open the file. Okay, and now I can say for line in my in file, I could do something like print the line. It's always a good thing to see if everything is working right. Okay, so yeah, all right, we printed those lines. But I'm actually interested in line 9, so let's count. Count the lines, and if count equals 9, we'll print the line. And if I'm going to do this, I better keep adding to my count. Plus equals 1. So let's try that. And if I look back, I can compare with my notes, or I can compare with the actual data file, and we see that yes, this is the line with the 3.1 and 0.2, etc. across there. So I've hit the right line. I'd like to save that line so I can work on it later. So I'll just call it line 9. And after my loop, I can print it. print line 9. So now what I've done is I've opened the file, I've found line 9 that I'm interested in a similar way I can find line 44. Now I might be interested in line 8, which has the years in it, because at some point I'm going to have to yank that out. And the other thing I do is that I think, let's say, I think I said that the data starts at well, let's see what it says here. It says the data starts in there it is. It says the data starts at column 76, and every one is 12 wide. So let's make use of that. So I'll slice this out. 76 up to 76 plus 12. I could do the arithmetic if I wanted to. And let's see if that works. Oh, I forgot. I did that out of line. I want to really do this out of, we see here that I made a mistake because I expected to find a 3.1, but I found 109.3. And that's because I had line, and I really wanted line 9. Let's fix that up. There we go. Now I get the 3.1, which is the value that I'm looking for there. And I if I want the next value, let's just take that line. And we'll add 12 there, and 12 there, and see if I get the next value. And I do. We can see now what I've done is I've got a 3.1 and a 0.2 and a 3.1 and a 0.2, so that seems to be working. I could I could do that again if I wanted to, and just make sure that I'm really getting these values. And now I've got the third one. So and you can see the pattern. Now you can go through, and how do you find the smallest one? Well, I'm going to go through each of these values and try and find the smallest one. And what I do is the algorithm, which I show in the description, says that we are going to start with some large value, right? And then for each value that I look at, so that's each value going across here, if the value that I have is smaller than the minimum value, so I start out with whatever that is, that's 10 million or something, right? And so I say, oh, is 3.1 smaller than 10 million? It is. Okay, so I'm going to call my minimum value, we'll have a value now of 3.1. And then I go look at the next one, and so my new value is 0.2. Hey, is 0.2 smaller than 3.1? It is. So let's get rid of that guy, and I'll put in the 0.2. Then I look at the next one. Is 3.3 smaller than that? No, it's not. Is 5.2 smaller than that? No, it's not. And I just keep going across, and oh, here's a negative 0.5. Hey, that is smaller than that. So we'll now keep track of that. And I go along. Until by the time I'm at the end, I will have found the smallest of those. But every time you do this, you also want to update your index. So like if I'm at the 0.5, that's 0, 1, 2, 3, 4, 5. Maybe I'm keeping track of this as how many of these that I went across here, and that way I can then use this as an index into my line 44. You'll have to figure out your way of doing that, but not only do I want to find the minimum value, but I want to know where it is so that when I look in the other line, I can get the corresponding one. So I give the algorithm for doing that, and then I require you to write a function that's doing that, right? So put that into a function, and I named that function find the minimum percent given a line. So you pass it in a line, you find the minimum percent, and you return two things, the value and its index, because we're going to need both of those later on. And then I'm going to go down and I'm going to do the same thing with the maximum, which is almost exactly the same function, but it's a little bit different. You know, like mostly it's got its, the Boolean expression is a little different. And then I take that, I take those values and I send them into this other function, the line and the index into it, right? And that will give me now the that will you know, and of course this is line 44 that I'm sending in, right? That's line 44 now. Before I was sending in line 9. So you know, where, you know, this will give me the GDP, and now, and I don't tell you how to do it. No, look at this. I can't count 4, 1, 2, 3. Huh? That should be step 5, step 6, step 7. I'm gonna have to fix that. Then after you do this, you're gonna still have to find the year that's associated with the minimum and the year that's associated with the maximum. How are you going to do that? Well, you might want to just write another function that will take a line and the index and tell you what the year is. That would be a perfectly sensible thing to do. In fact, I would suggest that. And just for a note, there are some students who've been reading ahead. And on this one, you're not allowed to use collections such as list tuples and so on. I want you to use strings and slicing on this one. So you're not allowed to do that. One final thing I want to note here is remember, we have this optional thing. We're asking you to help us out with some research. How do you feel when you got done with this? You know, I feel great. I'm annoyed. I feel inadequate. And then at the bottom, put these answer those questions there as comments at the bottom. We really appreciate it. We can only improve this course with your help. So help us out, and good luck with this.